Hello class, I hope you were able to understand the method of completing the square. It's a little bit maybe tricky, but if you follow the steps, you should be fine. What are the steps? Do you recall? Number one, make sure the constants are on the right side of the equation and the variables are on the left. Secondly, ensure that the coefficient of x squared is equal to 1. And then thirdly, you add the square of half the coefficient of x to both the left and the right side of your equation. Fourth, then, you would factor as a perfect square the left side of the equation. And you would collect terms on the right side. And lastly, you take the square root of the left, and you have plus or minus the square root on the right, and you write down your answers. It's pretty straightforward. I hope that you memorize that. Think carefully about it. Today we're going to be using completing the square, but we're going to be doing it on the generic form of quadratic equation. You remember the standard form of a quadratic equation is ax squared plus bx plus c. F of x equals ax squared plus bx plus c. And if we are solving for the roots, we will set f of x equal to 0. And then we would go ahead and use whichever method works best for us. So far, you know, you've solved quadratic equations. You've found the roots using factoring. You've used the graphical method, you've used completing the square, and today you will be using a method or a formula known as the quadratic formula, which is really just an application of completing the square, but in formula form. So let's go ahead and take a look at this, and hopefully it is clear to you and you'll be able to understand without a problem. You will need to memorize this formula. So, as you recall, f of x is equal to ax squared plus bx plus c. And when we want to find the roots, we know that f of x is equal to 0. So let's go ahead and write this in that fashion. Ax squared plus bx plus c equals 0. Now, if you look at this formula and think about it, what would happen if we tried to complete the square on this standard form of a quadratic equation? Never mind that a, b, and c are just represented by letters. What if we just followed the same procedure that we did for completing the square? What would we get? And again, you remember the steps. Take the constant to the other side. So this guy, take him over here, okay? That would be our first step. So let's write it out and see what we get. A x squared, okay, plus b x is equal to minus c, because we have to subtract c from both sides. So 0 subtract c is minus c. So here we are, ready for step number 2. Step number 2 is to ensure that the coefficient of x squared is equal to 1. Well, right now it's ax squared, not just x squared. And a, of course, could represent any number, but if we applied the same procedure as we've done before, to get 1 there, we need to divide a by a. If a is divided by a, that's equal to 1. So we divide both the left side and the right side by a. So we would have as follows: ax squared plus bx, divide all of that by a, is equal to minus c over a. Okay. So now we do some simplification. ax squared divided by a is just x squared, 1x squared, so we've accomplished that. Plus, in the second term there would be bx over a, or b over ax, is equal to minus c over a on the other side. Okay. Now, the third step was to do what? The third step was to add the square of half the coefficient of x to both the left and the right. So if you look at this, ask yourself, what is half the coefficient of x? Well, right now the coefficient of x is, let's do this over here. Right now it's just b over a. And if I want half of that, I will multiply by 1/2. So what's 1/2 times b over a? It's b over 2a. And then of course we want to square that. So you put a little square after that. So here we go. Let's work this out now. We'll have x squared plus b over ax plus b over 2a quantity squared. Is equal to minus c over a plus b squared over 4a squared. Okay, because I squared the b over 2a. So this expression right over here, b over 2a quantity squared, is equal to this right here, b squared over 4a squared. So we've added that to both sides. Now on the left, we can go ahead and factor, and hopefully that'll come out nicely for us, which it will, because that's what we're doing. We're completing the square. We're turning the left side into a perfect square. So this then factors as follows: x plus b over 2a quantity squared. And that, of course, is equal to what's on the right. Now, I'm going to turn the right side around so that it's b squared minus 4a squared subtract c over a. Okay, does that make sense? I just like to have that c over a after the other term, so I'm going to write that as b squared over 4a squared subtract c over a. Now, if you look at the c over a, and you look at the 4a squared, or b squared over 4a squared, notice the denominators on the right. So this guy right here, and this one right here, we need a common denominator between those two, and that is 4a squared. So how do you get 4a squared in the second term on the right there? You multiply top and bottom by 4a, So let's go ahead and see if we can work on that and get that done. So x, oops, go back to my black pen, x plus b over 2a quantity squared is equal to b squared over 4a squared minus, and again, we're multiplying by 4a on the top and the bottom. So this will be 4a times c over 4a squared. So now we have a common denominator on the right. We could actually bring that all together into one fraction, which we'll do. So this is x plus b over 2a quantity squared is equal to b squared minus 4ac all divided by 4a squared. Okay, now you look at the left, and remember when we got to this point, typically, in our solution by completing the square, we would take the square root of the left and the right. And that's what we do here as well. We take the square root of the left and the right. So what's the square root of this expression right here? What's the square root of that? Well, squared raised to the 1/2 power, the 2's cancel out and we just get what's inside, x plus b over 2a. So we get x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all divided by 4a squared. Now you look at the square root, the radical on the right, and you notice that the denominator, 4a squared, is the square of 2a. 2a times 2a is 4a squared. So we can rewrite this again and separate that right side. So we can write as x plus b over 2a is equal to plus or minus, lower that just a little bit, still looks tacky, the square root of b squared minus 4ac all over 2a. Okay, so that's our right side. And now, the next step in our solution by completing the square is to carry this b over 2a to the right side of the equation. Okay? And of course, we have to subtract it, right? So we have x equals minus b minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. Now, as you study the right side of this equation, I hope you see that we have a common denominator of 2a. These guys are the same. So what can we do? We can join those together into a single fraction. So the right side of the equation could be joined into a single fraction. So x, let me lower this a little bit, make sure I don't get crowded. X is equal to a nice big long fraction. I want a straight line. There we go. Minus b plus or minus the square root of b squared minus 4ac all divided by 2a. And folks, that is the quadratic formula right there. You need to memorize this formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. There you have it, the quadratic formula. This will identify the roots of a quadratic equation, irrespective of a, b, and c, provided, of course, we're talking about real roots. Okay, you must have x-intercepts if you have real roots. So it will not solve, it will not find x-intercepts that don't exist. Okay, but provided your quadratic equation has a graph that crosses the x-axis, then this formula will identify those roots. Now, for many mathematical things that we do, we prefer to factor or perhaps complete the square or something like that. But the quadratic formula is particularly useful when you're dealing with decimal numbers, with real-life problems that are involved in taking measurements. So if you're taking measurements of things and you're trying to do some calculations with maybe dimensions or quantities or something like that, where you have decimals, factoring becomes not really practical, and this turns out to be the best method. Of course, solution by graphing is another option that you could use. However, this will identify your roots a little more accurately. Graphing, sometimes you have to estimate, and it gets a little trickier. But this is very, very useful, and I think you'll find this formula to be rather easy to use. One thing I hope you have realized by now is that if this quantity in here, b squared minus 4ac, if it turns out to be negative, you cannot take the square root of a negative number. Stop and think about it. The square root means a number times itself, like 25 has a principle of square root of what? 5, right? 5 times 5 is 25, or negative 5 times negative 5 equals 25. But what if you had the square root of negative 25? That means two numbers multiplied together must be equal to a negative? No. A negative times a negative is a positive, and a positive times a positive is also positive. So if this number inside here that I've circled in red, if this happens to be negative, then you do not have any real roots. Instead, you have what we call imaginary roots, and it involves a funny little letter called I. We will not be talking about that in Algebra 1. Imaginary roots comes later in Algebra 2. You may wonder, what on earth is any of that used for? If I'm not mistaken, if I remember back to some of the engineering things I studied, I believe I sometimes is used in electronics. They can use imaginary things like that, imaginary numbers, to do some calculations. So anyway, here we have the quadratic formula. X equals minus b, plus or minus the square root of b squared minus 4ac quantity divided by 2a. Very cool. Memorize that equation. Say that about 100 times and you'll remember it. So, as we move forward now, what we're going to do is to solve a few examples. And those examples will be hopefully to help you apply this formula and know how to use it well. So our first example will be a fairly straightforward one. Example number 1. Okay, example number 1. Let's see what we can do with this. X squared minus 2x minus 15. Let's see how this little pen here, let's enlarge it just a little. Okay, so x squared minus 2x minus 15 equals 0. Solve this thing for x. So we use our quadratic formula. Very simple. X is equal to minus b. What's b? This is b right here. What's a? A is right here in front of x squared. It's 1. And c, of course, is right here. Okay. So let's initially here, let's identify a equals 1, b equals negative 2, C equals negative 15. Okay? So now that we have seen that, let's go ahead and solve for x. X is equal to minus b. Well, that's minus 2, plus or minus the square root of b squared. That's minus 2 squared minus 4 times a times c. This thing doesn't want to let me write in the corner of the screen. Hang on. There we go. Minus 4ac. Quantity, this whole thing over here on the right, is divided by 2 times a, which is 1. So we do a little simplification now. X is equal to 2, because minus a minus 2 is 2, plus or minus the square root of negative 2 squared is 4, minus 4 times 1 is 4, times negative 15 is 60. So this here happens to be plus, because minus a minus, all right, is going to be plus. 4 times 15 is 60. And it's all divided by 2. So it's looking a little simpler now. I think you can see that. Whoops, what just happened? Didn't do what I expected. Yeah, well, I guess I don't know how the eraser works. Anyway, let's go down a little bit more and continue our solution. So x will be equal to 2 plus or minus the square root of 64. Okay, all divided by 2. And what is the square root of 64? It's 8, isn't it? So this is going to be x is equal to 2 plus or minus 8, all divided by 2. So I have two roots now. First root is x is equal to 2 plus 8 is 10 divided by 2. Okay, so 2 plus 8, 10, divided by 2 is 5, or x equals 2 minus 8, which is negative 6. Negative 6 divided by 2 is negative 3. Okay, 5 or negative 3. Now, how else could you go about solving this? Well, just to check ourselves out and to keep you conversant with everything, let's go over here. Have a look at our Desmos graphing calculator. Y equals 2x squared, or sorry, 1x, just x squared, not 2x squared. X squared, okay, minus 2x minus 15. There it is. Look at our roots. You can zoom in on this guy. There's negative 3 right here. That one. Negative 3, 0, and 5, 0. So we've used the quadratic formula to find the solution. Okay? And we've confirmed it here with the graph that in fact it is true. Now, when you're doing your problems for this assignment, this upcoming assignment, this will be quite a lot to write in using the mathematical editor that we have within Moodle, using math type. It's quite a lot to write. So I'm going to ask that you do maybe not every step, but I do want you to show your initial step. I want you to show the equation setup. So make sure you show this. Okay? I want to see your numbers in the equation. To see that you placed them properly and that you have the correct signs. So you need to show that. Somewhere along the way, it would be good probably if you showed like this step right here. Because this is where you would see if you have a negative number inside the radical. And then, of course, you will definitely want to show your last step. This is going to be important, your answer. So you don't have to show each and everything along the way, but you do need to show the beginning, somewhere in the middle, like this, and then you need to show your solutions. So I need to be able to follow along and say, yeah, they were going in the right direction, or nope, they totally had missed it. So do show your work, okay? Let's go on and find another example, see if we can do another one. Example number 2. You choose a problem here. How about this one here? 2x squared minus 3x minus 6. 2x squared minus 3x subtract 6 equals 0. Let's solve this one here. Okay, what is A? A is right here. B is right here. And C is right here. So, quadratic formula. Okay. X is equal to minus B. That's minus a minus 3, which is 3, plus or minus the square root of B squared, minus 3 squared minus 4 times A, which is 2, times C, which is negative 6, all divided by 2 times A, which is also 2. Okay. So working this through, x will be equal to 3 plus or minus the square root of 9. Okay, 3 squared, 9. Negative 3 squared is also 9. Minus a minus over here, we have 2 times 4 is 8. 6 times 8 is 48. Negative 48, but you're subtracting negative 48, so it's going to be add like this. Okay. 9 plus 48, and the whole thing will be divided by 4. So what's 48 plus 9? It's going to be 57, isn't it? So x is going to be equal to 3 plus or minus square root of 57 over 4. Now, you could write 3 plus square root 57 over 4 and 3 minus square root 57 over 4, and that would not be wrong. However, you can also give the decimal equivalence. So let me just calculate the decimal equivalence, see what I get, and we'll write those down. So this turns out to be x is equal to negative 1.14, or x equals 2.64. So negative 1.14 or x equals 2.64, and I'm giving these to the nearest hundredth, okay? So that's a solution to a problem that you would have otherwise written as follows. You could have had x equals 3 plus root 57 over 4, or you could have had x equals 3 minus square root of 57 over 4. So these are the two ways you could have written your answer. Now, I'm just going to say follow the instructions in the problem. If the problem says give your answers to the nearest hundredth, then you give them like I did up above here. This would be to the nearest hundredth, okay? If I say give exact answers means no approximations, no decimal places. These would be down here, what we would call exact answers without any approximations. Now, honestly, in real life, most all of these types of problems are going to involve measurements. So when you're involving measurements, there is no such thing as exact. Any measurement is an approximation, hopefully a very good one, but still there's error in measurements, so therefore it's still an approximation. So anyway, follow the instructions in the problem that you're given in order to be able to answer appropriately. Okay, example number 3. This also works equally well for fractions. So here we go. 2x squared is equal to 5 halves x plus 3 halves. Okay. What is A? What is B? What is C? Well, you have to get things in standard form before you can answer that question. So let's move things around to get it in standard form. 2x squared, that's ax squared, plus bx. It turns out that I have to bring this across. So minus 5 halves x minus 3 halves equals 0. There we have standard form, and we can identify A, B, and C. A is 2, B is negative 5 halves, C is negative 3 halves. Now we can proceed to use our quadratic formula. X is equal to minus B. That's actually a minus is a plus, so this is going to be 5 halves, okay, plus or minus the square root of b squared. That's negative 5 halves squared minus 4 times, oh, sorry, minus 4a, that's 2 times c, negative 3 halves. And I divide all of that by 2a, 2 times 2, okay? So x is equal to 5 halves plus or minus square root of b squared. 5 halves squared is 25 over 4. Okay, plus this 2 cancels the 2 in the denominator of 3 halves. So when I multiply 2 right here, when I multiply this and this, they cancel. So 3 over 2 times 2, the 2's cancel. I'm just left with 3. 3 times 4 is 12, and a minus times a minus is a plus. So this just becomes plus 12. And of course, it's all divided by 4, 2 times a. Okay. Okay. So let's go ahead and simplify. So x equals 5/2 plus or minus the square root of, now here we have to do some simplification. We need a common denominator inside of the radical. We need a common denominator of 4. 4 times 12 is 48. So this is 25 plus 48 over 4. And the whole thing is divided by 4 again. Okay. Now, this radical here, the square root that we're looking at, notice the denominator is 4. 4 has a square root, and that looks like it might come out nicely. So this becomes x is equal to 5 over 2 plus or minus the square root of, what's 8 plus, or 25 plus 48? It's 48, 58, 68, and another 5 is 73. And this is over 2 now because the square root of 4 is 2, and the whole thing is divided by 4. And I always do this, it's annoying. I get my x way up there in the air, which doesn't make any sense. Should be down here, x equals like this. Okay. Now, we are to give, we could write this as one fraction. I could write it differently, but let's give our answers to the nearest hundredth and see what we come up with. So after working the numbers out, this is what we have. X is approximately equal to negative 0.44, or x is approximately equal to 1.69. Okay. There you have it, 2 roots. Do I have to put the little squiggly equal signs? X is approximately equal to. You know the little squiggle means approximately. Technically, yeah, because they're not exact. They're rounded off. However, I will be lenient on that. Sometimes we all get careless and we just put x equals. So if you just put equals, I won't mark you wrong, but do remember that they are rounded off. They're approximations. They are not exact. If you were to head over to the Desmos graphing calculator, I put this one in there for you to see. And if you zoom in on this, you should be able to see the roots very well. Get on this right here. Look at that. Negative 0.443. We rounded off to the nearest hundredth, so 0.44. And then over here, 1.693, or 1.69 to the nearest hundredth. Those are the two roots. Again, notice the y-coordinates are always 0 because these are the intercepts with the x-axis. It's where the graph crosses the x-axis, which obviously the y values are 0 because you are on the x-axis. So I hope this example was helpful. I could do more examples, but I don't know. I don't really think it's probably necessary. I think you're able to go on and do problems without additional examples. Maybe the only thing that could be maybe more confusing is if it was a word problem. Let me see if I can find a good word problem. Okay, example number 4. We have this equation, which is a model for the percentage of households that have high-speed internet beginning in the year 1990. So H represents the percentage of households with high-speed internet. N represents the number of years starting with 1990. So in 1990, N equals 0. 1991, N equals 1. And again, H represents percentages. So if we have N equal to 0, what year would that be? That would be 1990 if n was equal to 0. So if these guys here are equal to 0, what's the percentage of households that have high-speed internet? 1.5%. Okay? So I hope you've understood the equation well. Now, our problem is to find when, after how many years, will 20% of the households have high-speed internet. So what we're trying to find is when does this thing equal 20? 20 equals negative 0.2 n squared plus 7.2 n plus 1.5. When does this thing equal 20? After how many years? Solve for n. So what we do, we get everything on one side of the equation. Just because I would rather that a was not a negative number, although it really doesn't matter, I'm going to take everything to the left side of the equation. Everything to the left side of the equation. So I have 0.2 n squared minus 7.2 n minus 1.5 plus the 20 that's already on the left. So simplifying a little bit, okay, again, taking everything to the left and then collecting some terms, 0.2 n squared minus 7.2 n plus 18.5. Okay. So equals what? And I should have done that up here too. Equals 0, right? Equals 0. Okay. So I have so these two equations were equal to 0. Now, what is A? A is right here, 0.2. What is B? Negative 7.2. And what is C? 18.5. Pretty straightforward. We use our quadratic formula and see what we can solve. Now, remember the quadratic formula that as we memorized it was x equals minus b plus or minus square root of b squared minus 4ac all divided by 2a. It was x equals, but it doesn't have to be x. It can be n. So here we have n equals minus b. B is negative 7.2, so minus a minus is plus. So this becomes 7.2 plus or minus the square root of b squared, 7.2 squared. You don't have to put the minus sign, although you can if you want, because you know you're squaring it, it's going to be positive. 7.2 squared, b squared, minus 4 times a, which is 0.2, times c, which is 18.5, I'm running out of space, 18.5, all divided by 2a, 2 times 0.2. Okay. Now we want to do some simplification of this. Try to collect some terms, make it look a little bit better. N is equal to 7.2 plus or minus the square root of all that, all divided by 2 times 0.2 is 0.4. And we just need to do some calculations to find what's underneath the radical. So after doing a little calculation, we see that what's underneath the radical is 37.04. And now we have to go ahead and do the calculation to give the two possibilities for n. So after calculating the value of n, we see that we have two possibilities. Number one, n is equal to 2.78 years, or okay, n is equal to 33.22 years. So these are years since the year 1990. So if we add these number of years to 1990, we'll get the approximate year that we would have 20% high-speed internet. So 2.78 is close to 3 years, so roughly 1993, or roughly 33 plus 1990 is roughly 2023. Now, if you take a look at this function that we were given, namely this function right here, h equals negative 0.2n squared plus 7.2n plus 1.5, and you graph it and study it a little bit, you'll see some interesting relationships. Let's jump over to the Desmos graphing calculator and take a look. So here's the function that I've already put in. Notice that it's a parabola. It's opening down as we expected. We're asking when is h equal to 20%? And there are two places on this graph where it's equal to 20. You see here, h is on the horizontal axis. You see 20 right here. So zooming in so we can see a little more effectively. In 1990, we had 1.5, right? So this is 5. Here's 1, 2, 3, 4, 5. Let's follow this thing up. So right here at 0, we had 1.5. And if we keep climbing, notice at 3 years, we have 0.21. 4 years, we have, what am I saying? Not 4 years. Sorry, at 0 years, we have 1.5%. Okay. And then we have 4%. I'm sorry, 3% right here, 4% right here, 5% right here, and you can just keep going up. The question is, when does this become 20%? Notice that the x-axis, or n, is increasing as we go up. And we see that n is going up and up and up. N is the first number. H is the second number. So right here, 15% occurred roughly 2 years into this. We had 15% at 1.99 years roughly. And we just keep going up and up and up and up and up and up until we get to 20%. And you hold your mouse down there. We are very close to 20%. 20% is roughly at 2.8, and I believe we got a number of 2.78, didn't we, or 2.8? Roughly 2.8 is when we had 20%, okay? So if we keep following this thing around, we finally come to the place where we have 20% a second time, because what goes up must come down. See, this parabola goes around the top. Notice that as we follow it up, how high, what's the maximum percentage that this thing can have? 66.3 up here at the vertex. After 18 years, we would see 66.3%. But then after 18 years, at 20 years, for example, and on down, it falls. Does that make any sense? Does it make sense that our use of internet is going down? That's crazy. This is not a very good model, to be honest, but it is an interesting equation to study and take a look at, but it's not realistic. When you look at it in real life, it doesn't make much sense. So we see at 33 years, we're back to 20% again. See, we're coming down, 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 down. When we get to 20% again, it's roughly 33 years. Okay. And according to this model, we actually get to 0 after 36 years. After 36 years, we'd be at 0 use of the internet. Who knows? Maybe there's something else coming, but it looks to me like this is crazy. All right, so I hope this provides some insights into this particular function. So again, at 20% occurs at 2.78 roughly. It's hard to do that here. Actually, if I zoom in more, You know, when you zoom in really tight on something, you can get a more accurate answer. So if I follow this up now, I should be able to get a little more accurately. 2.78 at 19.995, or 20 exactly would be, yeah, I don't think I can get it. Well, that's about as good as I'm going to get. 2.78 anyway, 20%. So I think that deals enough with this particular problem. I hope you've enjoyed it, and I hope you'll be able to do your assignment without difficulty. Quadratic formula, memorize it. X equals minus b plus or minus the square root of b squared minus 4ac whole quantity divided by 2 times a. Have a lovely time doing your homework. We will talk next time. Bye.